Okay, hey Steve, I'm glad we're back. I'm glad that you've agreed to move us forward with this. I don't know what we're calling this, a Bergson-Bohm comparison or integration. We'll call it Bohm 2. Um, Following up on what we recorded a while back. So I guess just take it away, Steve, and I know you've created a presentation here of some slides. Let's just move forward.
Okay, this goes this goes for a little bit here, so we're gonna because we got a lot to look at
Yeah.
in Bohm, some of which we looked at already, as we know. So going back to the special relativity subject, first of all, um, the thing is, Bohm never abandoned special relativity, and by that I mean the special relativity that is the current view of special relativity. That is, that special relativity explains the twin paradox. And it explains why the twin on the rocket would age less than his brother that's left there on the Earth, who's the old guy, physically aged with a cane, etc. That's the ubiquitous version of special relativity right now. And that's what he was trying to reconcile his theory to. So, as I said, not only was he trying to reconcile to special relativity, he was trying to reconcile to the standard ubiquitous interpretation of special relativity that it explains things like the aging twin, the muon that's aging less rapidly as its velocity increases, the slowed clocks on the jets that are going around the planet, and like the half-like heating experiment, etc. So, as I said, this comes from Langevin's twin paradox in 1911, and this is where Bergson clashed with Einstein. Uh, in in the argument, Bergson argued that his rocket riding twin, Langevin's rocket riding twin, was aging less, actually, very physically, than his earthbound brother, had destroyed the logical consistency of special relativity, and that Einstein had created a reciprocal system. And remember, either person could declare himself at rest, and the other guy in motion. That's what reciprocity is defined as. And he had embedded the Lorentz transformations or equations in this reciprocity or reciprocal system. Mm-hmm. And by that, then all effects are what are called measurement effects. A.P. French, in his book Special Relativity, called them such. What's a measurement effect? Well, I measure my toaster with two rulers, and both are exactly the same length, but they're mismarked, shall we say. One is 6 inches long, one is 9 inches long. So depending on which ruler I use, the toaster expands from 6 inches then to 9 inches, or contracts from 9 inches to 6 inches. So this is obviously not a real, not an ontological effect. It's just purely a measurement effect, an effect of the rulers. The toaster isn't expanding or contracting. So in special relativity, the rulers are light rays and clocks. It's the same thing. And the rulers change depending on whether the clocks are synchronized or unsynchronized, depending on what the observer thinks. Okay, and a stationary observer thinks his clocks are synchronized. An observer flying by him says, but who happens to think he's at rest, and the first observer is in motion, says, no, your clocks aren't synchronized. And so that's where the equivalent of the expanding or contracting rulers comes in special relativity. So it was on this basis that the Michelson-Morley experiment was explained. The experiment had two arms, and one was parallel to the ether current, and the other one was orthogonal to the ether current, as this picture shows there. And Lorentz had proposed that there was an actual physical contraction of the apparatus arm that lay parallel with the ether. And that allowed the two light rays that were sent to each end and back to come back at precisely the same time, when by the Pythagorean theorem, one could compute that the light ray that was traveling in parallel with the ether should take a little bit longer than the one going orthogonal to the ether current. So the problem was this physicist didn't like that. It seemed, even though Lorentz had proposed electrodynamical arguments for this contraction, it seemed, I guess, according to the story, ad hoc to physics. And special relativity was preferred because there was no actual contraction of that apparatus arm. It was just a measurement effect. So everything depends, in explaining the Michelson-Morley experiment, on the interpretation of special relativity that is doing merely measurement effects, like our toaster situation. Again, I'm a little bit slow there, but okay, same thing, toaster situation in the Michelson-Morley experiment. And it's apparent, not an actual length contraction. That's the idea. It's a measurement effect. So when Langevin come along in 1911 with this hypothetical earthbound twin, and he's got his cane, long beard, gray hair, is very physically aging, more rapidly than his rocket-riding youngest brother had. Bergson argued, well, Langevin avoided the reciprocity of the two systems, which implied that either twin could be construed as aging more. You can just simply switch those systems.
Right.
And the Earth could be moving away from the rocket, and then back again, and now the guy in the Earth is the younger twin. And so basically, he declared that what could only be a measurement effect to be now an ontological effect, a very real physical effect, beards, gray hair, and all. He had destroyed special relativity's logical structure. This is Bergson's argument. But no, one can't declare the time changes, the aging, as ontological and leave the length changes as measurement effects in order to preserve the Michelson-Morley explanation. And why is that? It's because in Einstein's system, as Bergson noted, time units expand exactly in proportion as length units contract. The time and distance equations are compensatory, so they have to be of the same order. They must be measurement effects, or your whole explanation for Michelson-Morley dies, and you're back to the existence of the ether, which is probably where we should be. Thus, and this is what physicists did not want to accept, any use of special relativity to explain actual time changes, and I put time in quotes because you're not really explaining time changes at all. That's complete mythology. Is better the retardation of processes, and that's not equivalent to the changes of time. Yeah. The very real slowing effects of slowing of clocks and jets, like Havlickian, the longer lifespans of muons, is invalid. You can't use special relativity to explain real ontological physical effects. Only measurement effects. Only the rulers for the toaster. So Bergson had this exact argument in 1924 in Revue Philosophique with physicist Andre Metz. And Metz just could not get through his head that anything other than special relativity could explain the lifespan increases of mesons, or that's the old terminology for muons. I've had people say to me, "What's a meson? How come you're not using muon?" Because that was the old, terminology, nums. But anyhow, Bergson gave up on that. So physics needs a new theory to explain these, said Bergson. Special relativity can't be used. All the so-called confirmations of special relativity, or as Jimena Canales put in her book, The Stunning Confirmation of Special Relativity, they're invalid. They're stunningly non-confirmations. They're a misuse of special relativity. So here's an example I have abstracted from an obscure ether theorist, Jacob Kessler, The Energy of Space, 1962 self-published book. This is to help someone like Metz, or the physicists that can't grasp how there could be a different explanation that doesn't involve special relativity for those slowing muons. To Kessler, a muon, and as I said, he used the older term meson, is a group of positrons and electrons. So I've got a little group of positrons and electrons up there. A single positron-electron pair at rest annihilates itself. The positron accepts energy from the electron and radiates it away into the ether. So that is the pair, the positron-electron, has a certain lifespan at rest. So then if you get a group together, like I've got pictured there, a muon group, say 3 electrons and 2 positrons, as I'm showing you, gets in a synchrony. They feed off each other, but gradually they dissipate its energy to zero. This is its rest lifespan. But now put the whole group in motion. Now the motion generates a secondary counter electromotive force. And so I'm invoking here J.J. Thomas's electron model, where he saw an electron being a special case of electric current. No, we got electrons in there in that little group. The counter EMF, or secondary counter EMF, is a measure of the group's inertia, increasing to a singularity as the velocity increases. Simultaneously, the secondary counter EMF retards the rotation of the members of the group. The radiation away of energy is slowed down. The lifespan of the muon increases. The greater the velocity, the greater the retardation, and the greater the increase of lifespan. No magical, quote, changes of time, quote unquote, are involved here.
Right.
You don't need special relativity. You need, in other words, this would be a theory based in the ether that explains why the muons have a longer lifespan with greater velocity, or the clocks slow down with greater velocity, or maybe even the twin would slow down a bit and age more slowly. But this has nothing to do with special relativity, which can't be so used. I don't think I've got it said here, but on this assumes, by the way, clarity on a fundamental confusion that reigns throughout this literature, because the expositors of special relativity will immediately jump to the general theory and accelerations to explain all this. They'll say, well, because the twin was accelerated in a rocket and had to turn around at the acceleration at the star that it reached and then come back and accelerate to do so, this explains it. Well, but then you've got stunning confirmations of something in the general theory, but something that has nothing to do with the special relativity theory. You haven't confirmed jack as far as the special relativity theory, and this is an utter misdirected illusion that appealing to accelerations is somehow stunning confirmation of special relativity. So all this was Bergson's argument in his book, Duration and Simultaneity. And I always am confused between whether it's 1922 or 1923, but one of those 2 years. He argued that special relativity and its logically consistent structure, with all effects being measurement effects, and with its intrinsic reciprocity, preserve the flow of time as an invariant to all observers, and that neither twin age more or less than the other. And again, by reciprocity, the rocket twin can be equally considered to be stationary, the Earth twin moving away and back again. So now the Earth twin is aging less. Just reverse the situation. And in this argument, in duration and simultaneity, he pointed out this invariant flow. The invariant flow of time to both observers contains multiple simultaneous causal flows that cannot be relativized. So I'm picturing something here, like the opening of that rose is a simultaneous causal flow, as that organic growth involved. If you visualize all the points exploding and outwards in space, so to speak, and that is a simultaneous flow. Or a family eating and talking, or geese flying along over the river, which is also flowing, or sailboats before a pressure front, or even the iconic lightning bolts of Einstein coming from what's in effect a simultaneous flow, this massive storm. Imagine, for example, in this argument that you've got an organically growing blooming rose, make it considered about 10 feet across. You got the leading edge of 2 petals on opposite sides, strike 2 points, one on each side of the blossom, 10 feet separate. And they do so simultaneously to a stationary observer watching the rose. An observer moving by, but who thinks himself at rest, declares the first observer to be in motion, and his clock's out of sync. So we're back to the ruler problem, and the 2 points are not being struck simultaneously. But this is absurd. The organic growth of the rose, a simultaneous causal flow, cannot be relativized, not without destroying the organic growth. It's simple to demonstrate that there are causal consequences to the simultaneity of flows that simply cannot be made to, quote, go away. In other words, say they didn't happen depending on the relative motions of observers. As an example, let's change the rose to a growing tree. Two growing branches strike 2 points opposite the tree simultaneously, each branch touching an electric switch that sends a current towards a bell. The bell only rings if both currents with a combined strength hit the bell switch simultaneously. Presume the bell rings. The ring can't be made to go away. That is a valid claim made that it didn't happen simply because an observer watching the tree to be in motion. I'm sorry, an observer moving by in a rocket declares our stationary guy there, our stationary observer watching the tree to be in motion. His clock's out of sync, and the two branch strikes non-simultaneous. In other words, back to the ruler problem. The simultaneous organic causal flow of the tree's growth can't be relativized. In other words, the relativity of simultaneity is easily disproved. Even Einstein, as I noted, iconic relativized lightning bolts would in fact be part of a large storm front, a vast boiling organic system of flows like the rose. So the bolt strikes can no more be relativized in truth than the flows of the rose. How do they get relative? Well, they're relativized only via an artificiality, namely the mathematical characterization of time as a series of instants. And then this taking only instantaneous point events in what is in reality a larger flow. My little picture there, standard relativity picture, I'm taking two lightning bolts at an instant. Again, the observer, two moving by on the top there, saying, well, they're not simultaneous because the green observer his clocks are not simultaneous. But the Minkowski schema with its light cone and its interval I, which represents a causal chain, always proceeding from an instantaneous point. I've got that little picture there. Remember the light cones of the Minkowski schema. Everything in that, from event E1 there, in that cone is like the events E2 and E3 are can be causally influenced by E1 because they're reachable at the speed of light or less. E4 is too far outside, E4 to the left there is too far outside that light cone. It can't be reached in time at the speed of light for E1 to influence it. But everything's proceeding from that point, and not from a flow. And Bergson noted in Duration of Simultaneity, the theoreticians of relativity never note any simultaneity but that of two instants. So I'm not sure what I have here. I'm pointing to that point. And I think we're going to get there. Let's see. There's a chapter by Capek, 1966, in which he examines the Minkowski spacetime interval I, where I equals S, a little formula there, S being the 3D spatial distance between the two events at time 1 and time 2, or the distance between E1 and E4, say. And of course, you've got the time. So C squared minus T1 minus T2. And he argued that this invariant quantity defined a tripartition of event classes, which in turn preserves a form of universal becoming, as well as defines the relativation of events outside the light cone defined by I. So again, as I noted before, the events inside the light cone, E3 and E2, can't be relativized because they're all part of a causal chain proceeding from that point. E4 exist outside the light cone, outside of, so it can be it can be relativized. We don't know whether it actually occurred before E3 or before E4 or simultaneous with, etc. So those events outside the light cone are relativized, but according to Capek, there is a becoming for everything inside the light cone from that point. There is becoming, which we know Bergson was insisted on, that there is becoming in the universe, is preserved by this form of this vision of relativity. Um, though common sense would there's you can get easily describe situations, and this was what Nataza Rokic did, where E4 would have to be influenced by E1 and also simultaneous, say, with another event there was inside the light cone. And so, anyhow, however, this seems to be Capek's, that was his attempt to reconcile her special relativity to Bergson. But again, this is simply a causal chain emanating from a point. It has no reality. The point is actually part of a larger flow. In other words, if we were to take that rose and slap it right over the intersection there where E1 is, you'd have a much longer line of points initially. If you take the starting configuration of the rose, you've got a whole long series of points. An extended object, as we'll see, that's going to unfold over time. And this is what Myhrvold tried to say. He was looking at the pole-barn paradox. I think we mentioned that last time. And he said one should be referring to extended objects, taking a space-like slice, that is, an instantaneous stage along some foliation of the object's history. A space-like means, as we've been talking about, two events like E2 and E3 are separated by a spatial distance small enough to influence each other at the speed of light, or E1 and E2 are close enough spatially to influence each other. But see, now under Myhrvold's thing, we're just including the outer petals of the rose as part of a causal flow. And you could take the growth of the rose, going back to its natural speed, over 2 weeks, and it's all a nice space-like slice over 2 weeks. It's all in the light cone, and it can't be relativized. So it can be only relativized if, again, you take the two edges of those two outer petals at a micro instance. Now you've got a time-like slice because they can't influence each other. And the rocket physicist says, well, they're relative, but this is entirely artificial. You've simply gone back to ignoring the whole causal flow of the rose. Say, ignore that. We're simply going to look at this micro instant of time where these two outer petals, one on each side, hit the light switch, shall we say, and they're relative. They're relative. But again, that's entirely artificial. Just like Einstein's lightning bolts from the storm. There's simply no principled way to avoid extending this move of Myhrvold's to the whole of the universe, and saying, well, the whole thing is a causal flow. The whole transformation of the universal field is one of these simultaneous causal flows, and that's really what Bergson implied in Matter and Memory before he even wrote Duration and Simultaneity. Here's my making a larger line for my 300-mile long field or storm, or even a larger line for the universe.
But I just want to say, focusing on that micro instant, that's what Capek, in doing that, he makes his case. But
right.
I'm suggesting that that's not what Bergson.
Right. Exactly. So the whole point here, let me go we'll go back to the previous slide just for the heck of it. After all this, so I didn't sum up. Why did we say this? Because to unshock the listener from the idea that Bohm was completely misguided in trying to reconcile his theory constantly with relativity. And we're going to see this as we go shortly, that he always is referring back to special relativity and the idea that times can be different because, one clock A can be going slower than clock B, depending on the velocity of the clock, etc. He's completely buying the BS of current special relativity and its current ubiquitous exposition by every expositor I've ever seen under the sun. They mindlessly repeat this over and over. They utterly fail to grasp what's going on, including Capek.
Yeah.
Capek, argued against Bergson. He took his position against Bergson as well in his whole argument.
Right.
He invoked Bergson didn't understand accelerations. Sorry, that's a complete myth. Okay, so that's the point. We're gonna be seeing Bohm always referring to special relativity, deferring to special relativity. This is where he gets. I mean, this is such a fundamental misdirect that he's accepted that it's really difficult for me to go deeper into considering some of his theory.
Yeah. As you may or may not know, he really did struggle with his attempt to reconcile relativity with quantum mechanics. So.
And it's all because of this stupid mind program.
I get it. Yeah.
So anyhow, I hope we made that point. Now, Norson and Bohm. Norson in his, I don't have my picture of Norson's book here, but it'll probably come up in a second. Norson, remember, wrote a book. I don't remember, but folks won't remember, but he wrote his book on quantum mechanics, and one of that very interesting book.
Foundations of Quantum Mechanics.
Right. I'd swear I have another picture here, but I guess not. So let's. So in Norson, Norson was a great defender of Bohm.
Right.
And a great, the whole book was an exposition of Bell's theorem. Bell himself being a great defender of Bohm, loved Bohm's, pilot wave model. So here he's quoting Bell on Bohm's pilot wave model. We must simply conclude the locality, that is, the prohibition on faster than light causation that seems somewhat to be implied by special relativity theory is false. Relativistic local causality is wrong. It is in conflict with experimental data. Faster than light causal influences really exist in nature. Okay, contrary to the whole light cone picture that we were just talking about. This was the position of Bell, but indeed he went further. Quote, I would say the cheapest resolution is something like going back to relativity as it was before Einstein, where people like Lorentz and Poincaré thought there was an ether, a preferred frame of reference. Like, holy crow, he's saying this. This pre-Einstein position of Lorentz and Poincaré, Lamore and Fitzgerald, remember Lorentz and Fitzgerald, the contraction hypothesis, which physics rejected because it was supposedly ad hoc, according to this story, and I emphasize story, was perfectly coherent and is not inconsistent with relativity theory. But he can't be talking special relativity, because special relativity doesn't allow for any real ontological effects. And Lamore and Fitzgerald are real ontological effects, and Lorentz. The idea that there is an ether and these Fitzgerald contractions and Lamore time dilations occur, and that as a result, the instruments do not detect motion through the ether, that is a perfectly coherent point of view. Oh, yeah. So finally, I put up my picture of Travis Norson and the foundations of quantum mechanics. I knew it was going to be there. And I know Adam Becker, noted that this book, Norse's book, is the only true explication of Bell's theorem, which I thought was interesting.
That Becker too, by the way.
It's why I read, and it's why I poured over Norson, because he said, I ran across the video where he talks about that. Um, so keeping going. Why did Bell take so seriously these sorts of ideas, which everybody else today regards as completely outmoded and wrong? Because he thinks his theorem and the associated experimental evidence proves that non-locality is a fact of nature, rather than merely a defect of a type of theory we shouldn't believe in. Excuse me. Norson speaking of the difficulty of ditching relativity. Relativity, one of the most successful and highly confirmed theories in the history of science. Contemplate that sentence for a second. What have we just been talking about for the first 10 slides?
Yeah.
It's not confirmed. There is nothing confirming special relativity. It's complete mythology that it is so. So again, we're just frustratingly always flustered by these guys just thinking this is a iron stake in the ground that can't be moved. It's ridiculous. Okay, as I said, again, they're invalid. So I'm free these guys from this thing. Now, okay. So that's bringing us to another.
Yeah, you're on to a new topic here, the generative order. I just wanted to say though, the point you make in your work is, however, I like your phrase, everybody drank the Kool-Aid with regard to STR,
right,
including Bohm, and there's no doubt about it.
Right.
It's just shocking. It's just shocking
Right.
the extent.
Right. I think I put that the point of let's go back 1 second here to the point of all that was basically, I can't get there. That even though Norson and Bell are totally behind Bohm and his pilot wave model, they themselves are getting stuck with this mythology, of relativity. So we come to Bohm and the generative order. As he marshaled more thoughts on his total order of matter and consciousness, he related this again to time, again deferring as usual to special relativity. Quote, time may vary according to the speed of the observer. Then he notes what is important is SDR, special relativity's fusion of space and time. Again, he keeps deferring to this complete freaking myth. And notes, since quantum theory implies that elements that are separated in space are generally non-causally and non-locally projections of a higher dimensional reality, it follows that moments separated in time are also projections of this reality. Now, but they're not. But it's as you intuited. I mean, but this is a non-temporal order. There's no real time in this order. It's just like the intuitive model is what we're looking there, with the flat two-dimensional plane being like a flatworm. There is watching an expanding circle on his plane of his 2D plane of existence, and it just seems like it's expanding. He has no idea why, and the reason it's expanding is because there's this three-dimensional sphere going through the two-dimensional plane, and so what appears like motion in 2 dimensions for the flat planaria is actually what is a solid 3D object, a sphere with no motion in and of itself, though it is moving through this plane, through the 2D plane.
But
which
can I
should make you already kind of question the model because, well, but there is then this motion of the sphere going vertically up and down, isn't it? Where does that come from?
yeah, now can I ask you a question on this,
Because
Steve?
Bohm's model is that, it's just a sphere, but wait, the sphere is moving through the plane. How does that? Uh, it's not really coherent.
Well,
Okay.
does Bohm really need relativity to make, when he talks about the generative order and he's talking about quantum physics, he doesn't need special relativity to make the whole unfolding, enfolding generative order work, right? I mean, that's not important for that aspect of his work necessarily, is it? I mean,
Yeah, it is because
it's okay.
that quote there, time may vary according to the speed of the observer.
Yeah, I see what he
It's
said.
folded into his whole notion that there's different orders of time and different speeds of time
Okay.
in his static generative order.
And
There's different orders and speeds of time in that sphere that's now moving through the plane.
all right, I got you. All right, thanks. Thanks for making that clear.
I mean, again, so bottom line, well, it follows that moments in separated time are also projections of this reality.
See,
Well,
that's
I mean, so any particular state of the expansion of that circle, the black circle on the two-dimensional plane, would be moments separated in time, but they're just projections of that sphere going through the plane, according to Bohm. And yet somehow mm, the projection itself is a time, isn't it? Is motion, is becoming.
the
Uh,
okay.
yeah, I mean, just see
Yeah.
my struggle with Bohm and his models is like they really don't have. They look like they have coherence, but they don't. So let's go on this. So a higher dimensional spatial reality seems to sit above everything, somehow generating everything, all experience, all motion, all events. But yet somehow beneath the scenes, it itself has to be moving through some other, plane, like our 2D plane. I mean, coherence starts to dissolve, in my opinion.
Yeah, I've got to
Let's
think
go
about
on.
this some more. Go ahead.
Thus, he argues time has lost its primacy. Like space, it must be considered a projection of a higher dimensional ground with many orders of time. The orders of time came from that previous quote because of special relativity. Indeed, one can further say that many such particular interrelated time orders can be derived from different sets of sequences of moments corresponding to, wait for it, systems that travel at different speeds.
All right.
This
So,
whole thing is coming from special relativity's
all right.
bullcrap.
Okay. When he argues time has lost its primacy, it's because of his reliance on special theory of relativity. That's
Basically,
saying. Okay. Interesting.
and again, like I can go back to that model, the sphere going to it's like I say it's less coherence because time has lost its primacy, but well then what's projecting the freaking sphere through the flat
Yeah.
plane?
I guess I had hoped that his reliance on his reliance on STR wasn't that fundamental, but it is fundamentally important as you lay it out here. Yeah. That's crazy.
Yeah. So, but again, same
All right.
comment. But as we're seeing time changing as a function of velocity, just pure mythology of current SR. Further, Bergson's transforming kaleidoscopic whole, I think we'll come back. We probably talked about that already. Bohm's turning glycerin cylinder. Yeah, sorry, we got to go back. I thought I had a picture coming. Okay. His turning glycerin cylinder, which I hope people remember, unfolding ink drops as simultaneous holes, destroys the relativity of simultaneity in the transforming matter field. That is, this is real motion. Okay, if you think, it's just like we don't have. I don't have enough picture of the. Well, I may be in the next picture. I don't think so. The glycerin cylinder turning, but just there's multiple ink drops coming out of the glycerin cylinder, or could be, all simultaneously. Well, they're clearly simultaneous. So what happens to the relativity of simultaneity that he has to love and accept from special relativity in his own model? Again, coherence falls apart.
Yeah.
Go on. Similarly, we are led to propose that this multidimensional reality may project into many orders of sequences of moments in consciousness. Again, all this comes back from the special relativity thing. Not only do we have in mind the relativity of psychological time, the fundamental law then is that of the immense multidimensional ground. The projections of this ground determine what time orders came from special relativity there may be. Again, I say this whole thing is incoherent. I just can't get there. Somehow time, the transformation of the universal field, is projected from orders of sequences of moments in a multidimensional space. That's why I keep that flatworm picture.
I noticed the reliance on space over time, as opposed to Bergson. That's another
right. And yet, on analysis, it crumbles because he's got to introduce time somehow just to get that projection through.
Gotcha.
Somewhere, Ian. I go back to Bergson's quote: "Everything ultimately resolves to motion. That is the time." But I said this is all predicated, all on the wrong interpretation of SR. This kind of is what I'm kind of complaining about. It just kind of all stops you from the start. The spatial, again, as I've been insisting, I guess I started insisting before I put the point here. The spatial order has to be in motion, just like the ball. Motion, thus time, is still primary. What the heck put together that spatial order of the ball in the first place? I don't know. I mean, the problem I have with some of Bohm's stuff, it sounds beautiful, but that's the problem. It sounds beautiful until you
look under the hood.
Really open the hood a bit more and start thinking about trying to make sense of it. And because Bohm has such prestige, and he should have, nevertheless, that kind of hurts you a bit psychologically from opening the hood. You don't want to buy your Mercedes. Question the salesman that's selling the wonderful Mercedes. Impugn his integrity by thinking that maybe there's 42 chipmunks under the hood, with her pulling the rubber band, twisting the rubber band. That's my metaphor. Anyhow, so let's go on.
Well, just for completion's sake, I was going to say, can you go back to the whole fish tank thing? Because you didn't make a direct reference to that in your last slide, unless you're going to do it now.
Yeah, sorry about that. I got it.
That's a key component of his model, is the fish tank metaphor. There you go. Bohm's fish tank, the 3D projected. I think everybody who's familiar with Bohm knows how he uses it,
Right. I mean, again, it looks like the fish isn't correlated. It really comes to that higher dimensional, the three-dimensional fish tank. We're taking two orthogonal views of the fish tank with the two cameras. Notice even again the incoherence there, because that three-dimensional fish tank has got all kinds of motion and time in it, doesn't it?
Right.
It's hardly a static spatial order, is it?
It's a snapshot. That's right. It's a video, not a picture.
And again, you can translate the same thing to what the fish tank is saying to the flatworm case just above it. I mean, if the flatworm focuses on two points on that black circle as they expand, he's wondering why they seem to spread out simultaneously. Just like focusing on the fish, you wonder why its movement is precisely correlated as it turns toward you or away from you. Anyhow, so that's same difference, and it's got kind of the same problem in it too. Whereas that's hardly a static spatial order. So again, my argument would be, as Bergson argued, motion is still primary this time. And Bohm is basically, in my mind, working with the classic metaphysics of space and time still.
He puts more emphasis on space than time.
Yep. Remember, and we're going to talk about this again. For Bergson, this classic metaphysics is a mental diagram. It's a mesh we place into the concrete extensity of the external world. And by extensity, we're looking at, there's a nice picture of extensity, that lake surface and the shore, et cetera, et cetera. And it's before we place any conceptual framework of space over it. And that kind of a framework where we place over it as Bergson said, a kind of a mesh, a mental diagram. We can make those squares as small as we will, down to the mathematical point each square can become. In fact, what it is an abstract space, ultimately, of points and positions. Is infinitely divisible. According to Bergson, that's really a principle of infinite divisibility. So the motion of the cup through that space is treated as a line, as a set of points, a trajectory, a set of points. But between each pair of points, then, there's another infinitely divisible line of points, ad infinitum. So you've got, in this treatment of motion via this abstract space of points and positions, is an absurdity, because motion now becomes a set of immobilities, and it's an infinite regress, because between each pair of points, I can make another line of points, again, between each pair of those points, and that line, another line, et cetera, till I get to a mathematical point. A mathematical point is my stopping point, because such a point has no beginning nor end, so it's not, nor end, so it's not divisible anymore. So as that cup moves, each point of the cup's trajectory corresponds to an instant of time. So in other words, you're building up the fourth dimension of this abstract space. For every point of that cup's trajectory, there is the equivalent of the all of space. We'll visualize it as a cube. So it's an infinitely divisible 4D, four-dimensional abstract continuum. This is the basis of all mathematics. So the cubes of all of space each have the time extent of a mathematical point. So it's no longer a point being no longer divisible. Hence, each cube is frozen. There's no possible transition from cube 1 or space 1 to cube 2 to cube 3. So this is at the bottom of Bohm's sequences of moments. That is instants, this metaphysic. And no, Descartes, as Bergson noticed, saw the implication. Here you need God to create cube 2 once you have cube 1. You need to introduce a God to create each cube after each cube, because each cube is frozen. You can't get to the next cube. Each cube at that mathematical point is no longer the possibility of changing to the next cube. So you have to bring in a force to create the change, which is precisely kind of what we're talking about with Bohm's problem. What's creating the motion of that sphere through the plane that the flatworm is observing? So somewhere, as I said, in other words, somewhere behind Bohm's static order, the sequences of moments is a source of continuous motion.
Yeah, I mean, this is interesting. For me, I've always looked at the implicate order as being the glue, that would glue together each of those cubes. But you're making the point that where's the motion? Where's the movement coming from, correct?
right. Those series of cubes, space one, space two, space three, put them together in your mind. It's one, they're truly three-dimensional. They'd be one giant four-dimensional structure, frozen, static, no motion whatsoever.
Yeah. So,
And that's, of course, the problem with the space-time block of special relativity. Ultimately, where you say, "Well, okay, that's nice. You have a 4D block. How do you get motion? How now you've got then everything's an illusion. If I'm stirring the coffee, I'm perceiving that motion. That's an illusion because actually it's all a 4D extended block where there is no motion. Same problem. He's got the same problem. You have to have a theory of once you accept the 4D space-time block of relativity, which is essentially what my little picture there is with the three spaces, put them all together in your mind on a fourth dimension. Now you have the fundamental question, of a theory of the illusion of motion, the experience of motion. How in hell do you account for that now? Because the brain is just a four-dimensional, object along in that same structure.
okay, so
Everything. So you have to have something like a consciousness field moving over those blocks to create the motion. But then, of course, you have to explain how the consciousness field registers the motion, et cetera, et cetera.
okay, so that's the part that needs to be made clear, I think a lot of people can see his order as being the glue that glues the cubes together. And then he speaks of the generative order or the hollow movement, which is movement. But you're saying be a little more clear on the whole motion thing, because I think Bohm people say, well, yeah, there's the hollow movement. There's the generative order.
Where does that come from, though? Where does the hollow movement? You've got one vast 4D structure
right.
in Bohm's theory. It's frozen. You need Descartes' God to make it move somehow.
That's fascinating because I mean he would say, it's not a holograph, it's not a photograph, it's a hollow. I always looked at his theory as something to the effect of the universe is a moving hologram, and that's why he refers to the hollow movement. But your point
we're back to the you and I are back to the unrecorded conversation with your profound questions you asked me earlier. About how do you characterize Bergson as motion plus creation? We're back to that, evaluating that statement.
Right. All right.
Right here.
Very good.
All right. Well, okay. Let's see what's next here. It's all becoming a surprise to me. We're still on. Okay. So
good.
This is totally opposite from Bergson, where time is a force.
All right.
As noted, we must wait for the sugar to dissolve. He noted. Why do we have to wait? Because duration is the very stuff of reality. We must wait for the sugar to resolve. Only in an abstract space, that abstract space you can speed up or slow down the event at will, because there's nothing inherently generating the blocks. If you kind of think of that abstract space as my series of cubes all laid out, and I can transition from one cube to another cube as fast as I want to or as slow as I want to, because there's no concrete thing in my theory moving the cube from one to the next to the next to the next. Okay, it's just an abstraction. I can speed it up or slow it down at will. And of course, I don't even know what it is that I'm speeding up or slowing down. It's just because there's a purely mental thing that, there must be a cube 1, then there has to be cube 2, then there has to be cube 3. But I have no idea why, because it's in my abstract theory, it just all sits there, as a series of static cubes. So Bergson says the universe transforms, that universal field transforms at a certain pace, and time is a force. That's why you have to wait for the sugar to dissolve. And he says the duration of the universe, that is the paced unfolding of the universe, must therefore be one with the latitude of creation, which can find place in it. So that's kind of back to that other comment, the quote of his. Time is this hesitation before the next possibility, the next possible state of the universe, or it's nothing. Because, it's almost a hesitation before what's the next creative moment going to be? And that only moves so fast.
Right.
I can only dissolve that sugar so fast.
Right. Can I?
And then I don't know if I got it here, but I'm going to anticipate. That system, that little glass, is an arbitrarily demarcated system. The glass, the sugar, the water, all are such because of their relations with the whole external field, the whole field of the whole universe. So I am extending this concept to the whole. In actuality, the whole universe is unfolding at a certain pace, of which the glass and the water is a subfield, a subset of that whole field unfolding at a certain pace.
Okay. Can I come in here, Steve? Because I think we should make it
Yep.
more clear. Before we hit record and started the presentation, you and I were talking about this time as a force notion. And I was expressing to you how I've always struggled with Bergson's notion that time itself is creative, because I've been so infected by Bohm's work, and who worked with Jiddu Krishnamurti, for instance, and these guys would make a distinction between invention and creation. Invention took place in time where something exists and you move it around and something new is created, but that's not creation. Creation needs to come from a term that Bergson despises, nothingness, or Bohm and Krishnamurti spoke of a moving stillness from which creation can be generated. But my point, though, is with Bohm, you have this other order, which generates something else. So creation for me makes sense in Bohm because you've got this generative order notion. Now I've expressed this to you.
But hiding behind the notion is, but hiding behind that order is ocean. It's got to be motion itself. So
so that's my point. So I just wanted to say, though, I've tried to look at Bergson's duration as a Bohmian generative order, and I think I mentioned that to you once, and you said, you didn't really respond to it, but I've had in the back of my mind that why can't we look at Bergson's duration as a generative order, because it does unfold even matter itself. And what do you think of that notion?
You got to be careful.
I assume
because you can't imply that it's all there in that order and it's just unfolding.
In the generative order?
That's totally non-Bergsonian. Bergson would say, that's just teleology. You're just unfolding toward an already defined goal, and that goal isn't defined in reality.
And Bohm does flirt a lot with teleology. He really does. He does adhere to Aristotle a lot. Yeah. All right. So it's a subtle issue.
Remember, Bergson. He rejects both final in the evolutionary. We're talking about becoming here, okay? And he says he rejects both finalism and I forget what he called. We'll call it teleology. Or mechanism and finalism, where finalism is teleology, because mechanism is just a mechanical unfolding. Laplacian determinist mechanical unfolding, and finalism is just the same form of mechanical unfolding, all being drawn to a already specified goal or vision. Like I've got a mousetrap I've got in mind, and I'm unfolding all of the events, putting together my box and my pencil and my rubber bands, etc., all unfolding toward my ultimate mousetrap that looks like a crossbow. And he'd reject that too. Because neither of those actually affirms the creativity that comes out of duration. So,
Right.
yep, yeah, we're in tough subject here. So,
At least.
all right. So, shall we go on here?
Sure.
And now, as I preached already, the glass is an isolated system. No. What else can this mean that the glass of water, the sugar and the process of the sugar's melting are abstractions, and that the whole within which they have been cut out by my senses and understanding progresses? It may be in the manner of a consciousness. So the whole, being the whole universal field, is progressing at a certain rate. The very stuff of reality. Time is a force. And there's my little picture. In other words, the glass is just part of the transformation of the universal field. Okay, and then you go back to what he said in Matter and Memory. The whole is transforming. Even objects, quote unquote, and their emotions are in reality changes or transferences of state within this global motion. And that's already where you come to the simultaneity of flows that we talk about, that he later talked about in 1922 in Duration and Simultaneity. Because the organic growth of the rose is in reality just changes or transferences of state within this global motion. It's a simultaneous submotion within the global motion, along with Einstein's thunderstorm. So it's interesting because all the Bergsonians everybody I've seen commenting, they don't recognize that, they don't grasp how Bergson's comments in Duration and Simultaneity about simultaneity of flows was already there in Matter and Memory in 1896. In fact, I think he said it better in Matter and Memory than in Duration and Simultaneity, which I can understand because you forget what you said after it's 25 years later. Okay. So Bohm, I think, is envisioning this higher dimensional order as all following, it's all characterized by mathematical laws. Okay. But in Bergson's view, this too involves a misconception. See, I think if you ask, well, does all this unfold, Mr. Bohm, Dr. Bohm, by mathematical law? He'd say yes. Okay. Of course, and it all unfolds according to the laws of physics. Right? In my classic metaphysical framework of space and time, abstract space. It would have to. What's the misconception? Well, Bergson, a law, these kinds of laws are discovered by induction. You discover these because they're what's called invariance laws. So you do it enough experiments and you find out that, if I stir the coffee enough, it always makes the radial flow field. That's sort of an invariance law of coffee stirring. It's an inductive process. Right. But what he says is what this induction discovers is the law, the mathematical order is no positive reality. What does that mean? Well, it is the form toward which the interruption proceeds, he says. And so then we've hit this core of Bergson's vision again. We're back to our becoming. Okay. The vision is this: it is consciousness, the inextensive, that pushes the universe into existence. So I got my picture of the inextensive consciousness, but it's thrusting the universe into existence. But this push is an intensive force, but as it proceeds toward the world of matter, it's relaxing and lessening of this force. And it's the emergence of the extensive or the material world with its geometric tendencies. But the ultimate expression of this as a precise mathematical order treated geometrically in the abstract space with its points and positions of mathematical instances. that's an ideal limit. That arrow never quite pushes everything to the mathematical order that a physicist like Bohm would envision actually exists. It's that, and of course that's where all of science is making a mistake right now. They've exalted this mathematical order, which is an endpoint and an ideal limit, into the point in which you start. And it's not the case. It's not just like artificial intelligence also has exalted. It's simply an expression of the classic metaphysic. The Turing machine is this state to state, instant to instant model with its abstract manipulation of spatial objects, which they think is where you start the theory of consciousness. But it's not the point. That abstract space is a derivative of cognitive development of the brain, but the brain doesn't exist in that abstract space. It's created the abstract space. It exists in the temporal metaphysic, in time as a force. And so everyone's starting at the wrong point. They're starting from the end point, which is basically an abstract limit derived by the brain. And that's screwing everything up. So
Very interesting
again,
observation.
if you were to ask Bohm, this is my point, well, is this all unfolding by a mathematical order? You'd see, well, he'd say probably yes, and Bergson would say no.
Yeah.
Let me see if I got. Before I read this quote, I'm going to expand it because Bergson gives us an example of finding an inductive law in boiling water. Okay, and so you boil a pot of water, then you repeat the process the next day, then you repeat the process the next day. You're basically superimposing upon an ever-changing universe an abstract situation where you're pretending that everything is the same from day 1 to day 2 to day 3. You have the same pot, you have the same kind of, the water is basically the same, you have the same heat, and you're coming up with a law of boiling. And Bergson says, nature never dreamed of such a process, which is to say, it never dreamed of such a law. So, again, nature never dreamed of such a process. You got to sort of let that one. That's in creative evolution, right along with this, right near this area where he's talking about whether these laws of positive reality. They have no positive reality, but physics sure thinks they do. Bohm sure thinks they do, I think. So he says, quote, whereas the power of creation once given, and it exists, we are conscious of it ourselves because we can create symphonies, has only to be diverted from itself, to relax its tension, to extend, only to extend for the mathematical order of elements so distinguished and the inflexible determinism, Laplacian, shall we say, connecting them to manifest the interruption of the creative act. So, I mean, yeah, we'd have to go back and, again, you got to, when we, back to our original first discussion, we got to ponder all this in the context of your question.
Yeah.
But anyhow, I think that's all I have to say here on that. But I think the point being is, again, well, does this generative order really have the positive reality you think it does? I don't think so.
It's like you said, it's very subtle. We need to continue a discussion around this topic, I think, because I just want to go back to that last slide. It just sounds, like we said before we started the presentation, Bohm speaks of unfolding, enfolding from a generative order and back and forth. And then yet, Bergson still speaks of, like you just pointed out, tension, extension, but it's all of one order.
Right.
It's very subtle how this put out there.
Right.
I think at some point I would like to discuss, obviously not during this presentation, but I think it'd be worthwhile to bring in Krishnamurti's influence on Bohm and the whole notion that I mean, for instance, I'll just throw this out there. I was watching the 1975 Bohm Krishnamurti dialogues. The transcripts now exist. It has never been published, but I was watching dialogue number 10 yesterday afternoon, and they were talking about creativity, which ties into what we're talking about here. And Bohm makes the point. He says creativity itself is not created. And then they start talking about, Bohm says something like, perhaps even in nature, the depth which brings about something is not of time. The creation of new forms in nature may also depend on what's beyond time. So this whole notion of a realm that is still but yet in movement, which is generating creation itself. But it's a very subtle thing. But
right, and we've got a schematization of the problem right there with my arrow going up and down. What is that inextensive consciousness? Okay, that's generating the external world.
what is
right?
inextensive?
See, it has vague resonances to Bohm, right? As you say, a generative order, but it's not going to be the generative order that Bohm might be thinking, you know. But yet, it's something. When you say inextensive, it's not exactly what we consider. Well, this is another whole interesting question
It is
of
very subtle. Yeah.
is yeah of you know in is there really the inextensive in Bergson, and the reality is he started out that way in Time and Free Will, but then modified that everything had at least some extension,
See,
even
that's a
that
very important notion. Yeah. Okay.
right. So even that inextensive thing is kind of, you got to think about that. So though that's what he has in creative evolution. That's the picture, and I believe he uses the term inextensive. So,
Okay.
but yeah, you you could see. I mean, that little picture there isn't. It's it sort of looks the same as Bohm's. He didn't picture it this way, but the ball going through the two-dimensional plane. You know, but yet it's different. Okay. Um, I think we go to the next slide. We'll see a little bit more. When I think I have one more slide of the generative order.
Okay.
Should we do that?
Yeah.
So
We're
he's so he says there's two kinds of order, and these are generally confused. These stem from this is interesting. These stem from two movements of the mind. The natural direction is tension, continuous creation, free action. The inversion is extension, externally related elements, geometrical mechanism. In other words, that abstract space I described. So the second order, number two, there is geometrical. It's the necessary relation of cause and effects. The admirable order of the astronomical, like all the planets work, in their nice little orbits or whatever. And all can be foreseen mathematically. The first order is the vital or the will, a symphony of Beethoven. No less admirable in order, but originality, unforeseeability itself. Okay, and so if you went back to my little picture there of the inextensive cloud, okay, you'd have in that would be this first order, the vital or the willed, but it's not the same kind of order as the order of mathematical law that fits in the abstract spatial continuum of the classic metaphysics. So, if you were to say, well, Dr. Bohm, if you were to actually, and see, this is where it's just frustrating, because some of Bohm's discussion about like music, etc., almost gets to this. Like, well, really, we were talking about the first order, the vital or the will, the symphony of Beethoven, that is the generative order of, it ultimately generates the whole series of notes that Beethoven wrote out on, whatever was the 108 pages that it took to write the symphony,
Yeah,
In fact, I've got a picture there,
but notice
right
our
there,
language here, Steve. I just want, notice the use of the term order, one order, another order. And
Right. See,
I've always felt that for Bohm, order is more fundamental than time or space. And I know for Bergson, it's time that's more fundamental than order. Would that be a correct?
right, and you have to have the time to create the order.
Gotcha. Gotcha.
I think that's what's going on.
That's what's going on.
That's why it's so frustratingly close to resident. Bohm gets frustratingly resonant
I have to
to
say,
something in Bergson.
I think
But
anybody who studied Bohm deeply will agree with what I'm about to say. He really struggled with the nature of time. I give the guy credit, though anybody would. He really did a lot of meditating on the nature of time, and he did a lot of this with Krishnamurti. So he did see the problem of time. I mean, it was a paradox, if you will, if not more than a problem. It's more like a paradox. He admitted he said no one has understood the nature of time in his opinion, and he struggled with it. But he did more of an emphasis on the concept of an order as more fun.
Yeah. Oh, I think we're really getting down to the fundamental similarity and the fundamental difference all simultaneously here with him now. I think we're getting there as we
Yeah,
compare and contrast him to Bergson. By the way, the reason I have that little guy with the coffee cup there down in the bottom right is because that's voluntary action. Even that, just reaching out for that coffee cup and taking a cool drink, is coming from the willed or vital order. All right. Just in other words, our everyday actions, if as long as they're not automatic, robotic, are coming from
yeah,
this deep inner vital or willed order,
it's an important point.
and which leads to the problem of voluntary action and free will. But that's another interesting question. Let's peek ahead to the next slide because I think I said you want to maybe stop, but
Yeah,
see now we're going to get to this topic. Let me just go
the
forward
pulses.
real.
Wow. Well, can I ask? We've been going for an hour and 45 minutes, but this pulse
I know.
this is important to me. Do you want to move forward, or you want to wait for another day on this? Because this to me is crucially important. The Whitehead, Capek, Bohm, Bergson thing. How much do you have on this? Do you have a lot?
I'm going through them right now. Slide 20, slide 21. No, it's gone. Slide 22. 3 slides, but it's probably heavy. Then I go to Susskind and the holographic principle. A couple slides, 3 slides there. Oh my God, even more because
but these are important slides.
Yep, I got a lot on that too. Maybe we better do another. I'm probably running out of steam.
Right, okay, cool. But this is good.
Yeah, because there's about 5 or 6 on the holographic principle.
That's cool, man. I mean, but this to me, what we're about to hit, the pulses and then the holographic principle of Susskind, this is crucially important to get clear with regard to Bohm. So I agree. I think we should do another one fairly quickly, by the way, so all this stays fresh in our head. My schedule's fairly open, so if you want to do
Okay,
another,
we can just do this tomorrow. Tomorrow.
I can do tomorrow. All right, tomorrow
All right,
at 10 or 9.
10, yeah, at 10 again, or
10 o'clock your time, correct?
let's make it 10:30.
10:30.
I had to rush to finish my coffee.
Yeah, that's fine. So
But 10:30 feels better because I'm a little fresher. So, yeah.
okay.
Yeah, so the next two. Oh, and I have a final slide here on reconciling Bohm and Bergson, which I probably should look at before we talk. But yeah.
All right.
So basically, I've got 2 more topics.
Right. Got a lot of content.
The pulses topic and the holographic principle topic. There's still, like 10 slides here, I think. So,
and then you have a conclusion at the end.
I got a little, reconciling Bohm and Bergson, which I think we actually did a better job on than this slide does at this point. So, but I'll look at that slide again. It's a good thing because I think we just saw one point where you'd reconcile Bohm and Bergson, and that would be in this the order is in reality in Bergson's this intensive
Yeah.
You know, the
Yeah.
willed vital order that it requires time to even come about.
Gotcha.
You know,
That's a very important notion to meditate on with regard to birth.
yeah,
Yeah. Okay.
yeah. I think because getting even down even more simple is like uh, it's back to that. For Bergson, time was a reality, and for Bohm, it wasn't.
No,
You
that's
know,
right. It wasn't a fundamental portion of his
right?
vision. Yeah. So, but then again, I'll tell you what, that's going to tie into what you're going to do tomorrow too, the whole pulsation thing.
Right.
All this, so that's important. So we'll come back to this content tomorrow, I'm sure.
All right.
Okay, so I'm going to stop recording and